Conic sections, hyperbola. So today I'm gonna discuss about hyperbola. So hyperbola is a conic section, a set of all points in the plane formed by the intersections of a plane perpendicular to the basis of a double cone. Basis of a double cone. So a hyperbola can be horizontal or vertical, and this is how you divide a cone in order to create a hyperbola. So this is an example of a hyperbola. Now with that illustration, let's proceed with its parts. So the center is designated with the H and K as its points for the graph. This is the center. Then foci are the 2 points, just like in the parabola. It's this one and this one. The vertices is where it intersects this one, for the same as the parabola there. The two is V1 and V2. Transverse axis is the line segment that passes through the center, and the endpoints are the vertices. So this is an example of a transverse axis. As you can see, it passes through the center, and the two endpoints are the vertices. So next is the co-vertices, and with it is the conjugate axis, where it's just like the transverse axis, but the difference is its endpoints are the co-vertices. So as you can see, these are the co-vertices, and this is the center, which means the line that passes through the center and endpoints are the co-vertices is called the conjugate axis. Now let's proceed with the basic formulas that are found in hyperbola. So the three parts, which is the foci, vertices, and co-vertices, has similar formulas that depends on the orientation of your hyperbola. For the foci and co-vertices, it's quite similar because as you can see, if your hyperbola is horizontal, you will add, for your foci, you will add and subtract your C to your H if it's horizontal, and for your co-vertices, you will add and subtract your B to your H. And if it's vertical, if the hyperbola is vertical, you will add and subtract your C and your B to your K. And that's how you get the co-vertices and foci. Well, in the vertices, it is different from the two because it's the exact opposite. If your foci and co-vertices are found in the horizontal part of your graph, your vertices are found vertically, not horizontal. It's not in line with the two. So yes, you will add your A and subtract your A, add and subtract your A to your H if it's found in the horizontal part, and add and subtract A if it's in the vertical part. In your transverse axis, you will use your A and double it, and that's how you get your transverse axis. For your conjugate, you will twice your B, and that's how you get your endpoints. Your conjugate axis, where you can find your endpoints for your co-vertices. And simply, that's how we find hyperbola and its parts. How we define hyperbola.
The standard equation of the hyperbola in horizontal is x minus h squared over a squared minus y minus k squared over b squared equals 1. For the vertical, y plus k squared over a squared minus x minus h squared over b squared equals 1. This is for the standard form. For the general equation, ax squared plus cy squared plus bx plus ey plus f equals 0. AC should be less than 0.
We know our hyperbola is opening left and right because our positive term is on this x, which immediately means that our a squared is 6. So let's solve for our center. Our x coordinate would be -5 and our y coordinate would be 2. That means our center would be -5, 2. So since our hyperbola is opening left and right, that means our vertices would be constantly changing on the x-axis. So our formula for getting the vertices is h plus a k and h minus a k, which our h is -5 and our k is 2. So let's start. -5 plus a, which is square root of 6, k, 2. And our next vertex would be -5 minus square root of 6, 2. We will be naming this as V1 and V2. So our next thing to solve is foci, which then again our foci would still constantly change on the x-axis but would still remain the same on the y. So let's start. This is our formula for finding the foci. H plus ck, h minus ck. The same as the first one, but only c would be changing. Our h is -5 plus c, which is c squared, is equals to a squared plus b squared, which is 6 plus 4, that is square root of 10. Then our asymptote, which these are our formulas. Y minus k is equals to plus b over a x minus h. This asymptote is going like this from our left to the right. It never intersects our hyperbola. Same goes for y minus k is equals to -b over a x minus h, which our asymptote would be from our right to the left. So let's start. Y minus k, which is 2. I'm solving for this, plus b, 2 over a, which is square root of 6 x minus 5 plus 5. And next is y minus 2 negative 2 over square root of 6 x plus 5. Looking for the length of the transverse axis, which our formula would be 2a, which our a again is square root of 6, so it's 2 times square root of 6. And for our length of conjugate axis, that would be 2b, which is b squared is 4, b is equals to 2 square root of 4, so it's 2 times 2, 4. Which determines the roundness as well of our hyperbola. So our formula would be c over a, which our c is square root of 10, and our a is square root of 6, which is square root of 10 over 6. Our lowest density would be 5 over square root of 5 over 3. Next would be our length of the lateral recta, which our length of lateral recta, our formula would be 2b squared over a, which our b squared is 2, our a is square root of 6. our b squared is 4. So it's 8 over square root of 6. Rationalize. Would be 8 square root of 6 over 6. Simplify, that would be 4 square root of 6 over 3. So for our lateral recta, this would be our formula. Our b squared is 4. Our a is square root of 6, which is 8 over square root of 6. Rationalize. That would be 8 square root of 6 over 6. Simplify. That would simply be 4 over square root of 6 over 3. For our endpoints of the lateral recta, this would be our formula, which is a half of the lateral recta formula a while ago, which is b squared over a. Our b squared would be 4 over square root of 6. Rationalize. That would be 4 square root of 6 over 6. Simplest form, that would be 2 square root of 6 over 3. Next would be our endpoint that will be basing on our f1. It passes through f1 and f2, which is f1 of negative 5 plus square root of 10 2 and negative 5 minus square root of 10 2. Here we would be, since it passes through f1 and f2, that means their y coordinates would be changing. So our first endpoint would be R1, which is negative 5 plus square root of 10 2 plus 2 square root of 6 over 3. R2 would be negative 5 plus square root of 10 2 minus 2 square root of 6 over 3. And for R3, which is basing on F2, it would be negative 5 minus square root of 10 2 plus 2 square root of 6 over 3. The graph, this green would be our vertex 1, and this green would be vertex 2. This is our center. This is our foci 1, foci 2, and this one, this orange dots would be our R1 and R2. This one would be R3 and R4. So here we have the graph. You can plot it here using this coordinate. So here we have the coordinates. You can graph them using your graphing calculator if you have. And if it is like this, you can just calculate them with the calculator, and then you can see the exact coordinates where to plot them. So that would be our hyperbola. Thank you.
So, for this problem, we're going to write an equation in standard form with these specific features of hyperbola with center at -2 and 4 transverse axis of length is 8, conjugate axis of length is 6 if it opens to the left or right. So, this is the standard form of hyperbola. Now, all we need to do is determine from what is given on the problem to resolve the equation. First, we have to identify which is h and k. H and k is also defined as a center for all conics. In the problem, the center is -2 and 4, which is h is -2 and k is +4. Now, let's look back at the given. Transverse axis is also defined as 2a, which is 8, and the conjugate axis as 2b, which is 6. In order for us to find the a squared in the formula, you have to divide the transverse axis, or 2a, which is 8, divide by 2. So, 8 divided by 2, it will become 4. And the conjugate axis, or 2b, which is 6, divided by 2, it will become 3. 4 and 3 is your a. You have to square them both. So 4 squared is 16 and 3 squared is 9. To square numbers, you just have to multiply the number by itself. In this formula, your a squared is 16 and your b squared is 9. We've determined what is h and k, or the center, and the a squared and b squared. Now, all we have to do is substitute. Remember that when you substitute, the sign will be opposite. So the final answer is x plus 2 squared over 16 minus a minus 4 squared over 9. The hyperbola opens left and right because the transverse axis is x, and x is positive.